Create a PDF for the binomial random variable B2 0.7. Okay, so how do we make a PDF? Well, we need to know the possible outcomes, put them on one side, and then the probability that our random variable is equal to that value on the other side. And that's what PDFs always look like. So we need to first figure out, well, how many values can this random variable take on? And this is where we have to actually interpret properly. So 2 is the number of times we're repeating some experiment, the number of trials. Okay? So we only have 2 experiments that are running. So how many possible successes, because remember binomial random variables like B and P count the number of successes that have probability P that occur if you run your experiment n times. Well, if we've only got 2 trials, you could have 0, 1, or 2 of the outcome we're interested in, the success outcome. You can't have 3, because how could you have 3 heads if you've only flipped a coin 2 times? Doesn't make any sense. So now we've got to move on to the probabilities. Fortunately, there's a nice little formula for that. Okay, always n choose k, p to the k, 1 minus p to the n minus k. Okay, we have the information. We know the k values we want. So n is 2, choose 0. The probability of the outcome we're interested in counting is 0.7. So 0.7 to the 1. 1 minus 0.7 to the 2 minus 0. I said 1 a second ago. It's 0.7 to the 0, which is equal to 1. Okay, and then 2 choose 1. 0.7 to the 1. 1 minus 0.7 to the 2 minus 1. 2 choose, now we want 2 successes. 0.7 to the 2. 1 minus 0.7 to the 2 minus 2. Okay. Now we could leave it like that, but we could clean things up. 1 minus 0.7 is 0.3. And we can also clean up the exponents. 2 minus 0 is just 2, 1, 0. Okay. But anything to the 1 is just itself, so we can drop that. Anything to the 0 is 1, so we can get rid of those. Okay. Anything choose 0 is 1. Anything choose itself and choose n is always 1. And 2 choose 1 is small enough that we should know it. It's just 2. Okay. And now we can just work these out. So 0.3 times 0.3. 3 and 3 is 9. 2 numbers after the decimal place. So we move it over twice. So this is 0.09. We can do the same thing with 0.7. 7 times 7 is 49. We'll just have single digits after the decimal place, so move it over twice. We can replace the 0.7 squared with 0.49. If we didn't want to work out the middle one, we've got the first and the last ones, and we know for a PDF the probabilities all add up to 1. So 0.09 and 0.49 add up to 0.58, so that leaves 0.42 left. Okay, so we could do that, or we could just multiply. Okay, get 21, move the decimal place over twice, 0.21, then don't forget to multiply it by 2. Okay, 2 and 21 is 42, and we still just have 2 digits after the decimal place, so we move it over twice. 0.42, and there is our final answer with nice, neat, worked out probabilities on the right-hand side.